Now, pedigrees. A pedigree chart can help trace the phenotypes and genotypes in a family. Boxes represent males and circles represent females. A shaded box means the person shows the trait, and a white unshaded box means the person does not show the trait. Now we're going to create a pedigree. I'm going to ask you to forgive my poor handwriting. I don't have a stylus. So we have Mr. and Mrs. Cooper married. So we have Mr. Cooper married Mrs. Cooper, male, female, and they had 3 children. Sheldon, male, and Kaylee, circle, close, and then Bradley, male. Sheldon married Amy, so we have Sheldon marries a female, and they had 2 boys, Raj and Howard. 1 boy, 2 boys. Kaylee married Leonard, so she marries a male, and they had a boy, Stuart, a square, and a girl, Bernadette. Bradley remained childless. Sorry, Bradley Cooper. Now here's where it gets a little confusing. Having dimples are a dominant trait, and having no dimples is a recessive trait. So we're tracking those who do not have dimples. And the following people do not have dimples. We have Sheldon. He has no dimples, so I'm shading him in. And Sheldon's firstborn, Raj, does not have dimples, so he gets shaded as well. Also, Stuart and Bernadette, Leonard and Kaylee's children, and then also Bradley. Sorry, Bradley Cooper, you just had a string of bad luck. So having no dimples is recessive, and I'm going to call the alleles D. So since it's recessive, you have to be homozygous. You have to have 2 of the alleles. You have to have 2 of the little d's. So right now we know that Sheldon is homozygous recessive. So is Raj. So is Stuart. So is Bernadette. And so is Bradley. That's a D. Now we have to solve for everyone else. We have Howard, who's right here. Well, he gets an allele from his mom, an allele from his dad, Sheldon. Sheldon only has the little d's. He only has the recessive alleles. So Howard must have 1 small allele. But he does have dimples, so he also must have a big allele. He must have the dominant allele, which he gets from his mom, Amy Farrah Fowler. So we would say that Howard is heterozygous. He has 1 of each allele, a dominant and a recessive. The dominant from his mom, the recessive from his dad. Moving on to Amy. Amy has dimples, so she must have the dominant allele, which we know gave to Howard. But also, her son, Raj, is homozygous, so he gets the recessive allele, 1 from his dad, but he also must get a recessive allele from his mother. So Amy must be heterozygous. And then now we go to Kaylee right here. Kaylee has dimples, so she has the dominant allele, but both of her children, Stuart and Bernadette, have the recessive allele, so she must have the recessive allele as well. Also, Leonard has dimples, but he must also have the recessive allele. So both Stuart and Bernadette, their children, get the recessive alleles from their parents. And that's the pedigree for the Big Bang Theory. Now this is a pedigree for color blindness. So color blindness is a sex-linked trait, which means it's going to be located on the X chromosome. Remember, females are XX, males are XY. And that's all you need to know, and it's carried on the X chromosome. So to make your life easy, you can label all of the boxes X and Y based on what they are. Circles are female, XX, males are XY, etc., etc. So I labeled all of the sex chromosomes for the chart. So what is the genotype of number 3? Number 3 is right here. Well, she is going to be XX. It's a female. And she has a son who is colorblind. Now, and the son is going to get that X from his mother and the Y from his father. So that Well, the mother has normal vision, so she must have the dominant allele. But she gives a recessive allele to her son because he's colorblind, so she must be heterozygous. She gives that small allele, that's a little b, to her son, and he's colorblind. So, like the last one, what is the genotype of number 7? Number 7's right here. Well, it's a female, XX. She can see color, so she has the dominant allele, but she also passes on a recessive allele to her son. So she must have the recessive allele. She also passes it on to her daughter. But she passes on the dominant allele to number 14 and number 15. So she's heterozygous. So now we move on to part C. If number 13's right here, marries a normal vision man, what is the probability that their son will be colorblind? So normal vision man is going to be XY. So normal vision, he's going to have the dominant allele, and then the wife is going to be here, and she has 2 of the recessive alleles, because she is colorblind. Now, we're only really concerned about what their son will have. Oops, did not mean to do that. So we're only concerned about what the sons will have, and the sons are going to be X, Y. So we don't really care about the daughters for right now. So the sons get the Y from the dad and the X from the mom. Well, the mom only has the recessive allele to give, so the sons will be colorblind. So the probability, 100% probability that the sons will be colorblind. Now the daughters are a different story, because the daughters are going to get the dominant allele from the dad, but the recessive allele from mom. Dominant, recessive. So the females, the daughters, are going to be heterozygous. They have 1 of each allele, and they're going to be carriers, because they can see color. They have the dominant allele, but they carry the recessive allele. Now for part D. Number 15 marries a colorblind man. What is the probability that their daughter will be colorblind? And we're going to show our work. So number 15's right here. So she is XX. She gets 1 X from her mom and 1 X from her dad. Her dad is XY, but he has the recessive allele. So she's going to get that X from her dad. But number 15 can see color, so she has the dominant allele as well, which she gets from her mom. So we know she's heterozygous, and she marries a man who is colorblind, so he's going to have the recessive allele. We're focusing on the daughter, not the son. So daughter is going to be heterozygous. And the second daughter, XX, she gets a recessive allele from a mom and a recessive allele from her dad. So this is genotypes. So 50%. 50% chance that the daughter could be colorblind.